So we're almost at the end here. Um, so let's talk a little bit about research directions. Um, as Mark presented some of the stuff, by the way, uh, one thing that Mark did not mention that I would like to mention because it's kind of a painful part is that right now, if you want to publish a paper in these topics, interaction design, and if you want to publish your results now, both ISMAR and IEEE and Kai are asking, did you get ethics approval? Did you get your experiment approved by the ethics approval board of your university or hospital? Yeah, and that's a non-trivial part, at least in my university. That's the part I dread the most when starting to do the evaluation. We have to convince the ethics approval board that we don't get people too simulator sick when using um, our prototypes, and that we are not violating their privacy. At least in Europe, that's a big issue, and everywhere. So anyway, the new design tools, so we are focusing on this side, high fidelity, low effort, zero code. In our course, we are still using, in my university, we're still using Unity, but there are ways of doing that. And I'm not talking about vibe coding, very inefficient but entertaining. That's some definition of, I've heard of vibe. Um, One thing that excites me a lot is this designing for new input modalities and devices, especially multimodal input, where you can combine different gestures, speech, body posture, etc. And using AI to support design, of course, content creation. That's a big item there. We have now tools that allow us to develop lots of things using generative AI, but virtual worlds, there is still quite a way to go. Developing three-dimensional, explorable, interactive content. I believe that the design path will be from videos to 360 videos and then to virtual worlds. That part, there is already stuff that allows you to create 3D objects, but whole worlds, it's still a little ways to go. And another thing that excites us, both Mark and I, it's collaborative and social extended reality. Uh, Designing for social presence, there are interesting things happening there, and ethical issues such as privacy and security. I would like to call your attention for a review of prototyping tools. That's a little bit recent from um, Freitas et al. Published 5 years ago a systematic review of rapid prototyping tools for augmented reality, published in the symposium on virtual and augmented reality, SVR. Uh, and you can find this on the IEEE Digital Library. That's a reproduction of, then there's here a range of tools developed that where you have the dimensions of the skill required, where Unity require and Xcode and Vuforia require you to have a good knowledge of programming, and then you can go to low prototyping tools. As you see, paper prototypes and storyboards are accessible to everyone. Play models, yes, you can do that. Wizard of Oz, we've not discussed that specific technique, but um, PowerPoint and Keynote videos, Paint AR, Sketch in Vision, some of the ones that we've discussed here. Tilt Brush 360 Proto are some of the ones that we have. So, and the level of fidelity is the other dimension. So Unity, you can develop virtual worlds and with rich interaction techniques, but it requires coding, lots of coding. Well, even Unity these days allows you to get templates. You can get interaction techniques incorporated into your Unity module, and that is the bootstrapping costs. And so we would classify the authoring tools in 5 different classes. So basic skin-based interactions like the mobile web, you have Sketch, you have Figma. That's a good wireframing tool, and Proto.io. Basic AR and VR scenes and interactions, you have Kula, KR Panel, Reality Composer. And then you have other tools like Snapland Studio and Shapes XR that focus on XR interaction. And then you have the other tools like Blender, Maya, and SketchUp that allow you to create 3D content in a relative simple way. Blender is free. Maya and SketchUp are commercial products, as you know, although I believe that both of them have student versions, of course. And then native applications, you can develop them in Unity 3D, Unreal, or A-Frame. And there's a good discussion, a paper that you can refer to by Nibbling and Spiker. The trouble with augmented reality and virtual reality authoring tools, which was published in this symposium in ISMAR a couple of years ago. So you can classify the XR prototyping tools across these 2 dimensions, level of fidelity and skill and resources. So in the class 1, you have the wireframing tools. In class 2, you can, but these are mostly the desktop and mobile applications, especially in the case of Figma. And then you can move on to class 3, where you can already develop some XR content like Shapes XR and Lens Studio. And then you can, this level of fidelity, SketchUp and Blender really do not give you interactive content or lots of interactive content, but allow you to create 3D shapes. And then you have the class 5, which involve programming and 3D content. So what we would like to have fast tools that would allow you to develop more content, and this is where the action is right now. So tools where we would like to have a low to medium fidelity interactive content developed with low skills, and the other one would be to have easy to use zero code prototyping tools that to allow you to develop high fidelity environments, possibly with the help of generative AI, of course. Everybody does generative AI for the, but that's where there is research opportunity. What are the challenges? Generative AI is good at generating 2-dimensional content, but 3-dimensional content is a little bit of an issue. You can use stable diffusion techniques to go from prompts to pixels, but going from prompts to voxels or to other more structured content is still a research issue. So here you have an example of tablet-based video prototype, Pronto. So allows you to do sketching on top of real-world scenes, tracking user positions changes, and direct manipulation of content. There's a paper describing it and a short video. I'll try to...
We've developed Pronto, a video prototyping system to help you rapidly prototype dynamic AR designs. Because the video also captures AR data, I can see an avatar of my tablet directly on the video.
So you see it's a real user.
Here's the final result. This video prototype was created in less than 4 minutes. Participants used Pronto to explore a wide range of creative AR ideas and advanced interaction mechanics.
Okay.
We developed
And another example of a prototyping tool is Flowmatic, which allows you, it's an immersive authoring tool for VR, allows you to create content and do visual programming techniques. The idea of visual programming is that you, instead of writing text instructions, you can connect functional boxes using a data flow paradigm to create small programs. And this is an example of visual programming, where you can use functional blocks and then connect their outputs to the inputs of other blocks, etc., to describe how different interactors work. And we have a small video. Oops. Okay.
We present Flowmatic, an immersive authoring system that allows users to create interactive and functional applications directly while immersed in VR. Flowmatic integrates concepts of functional reactive programming and provides a set of programming primitives that can be directly manipulated in a visual flow-based diagram. Our system enables novel functionalities, such as programmatically generating new objects, defining their reactive behaviors, and abstracting and reusing functionality.
An example of visual programming. Okay, something that Mark referenced a little while ago and also gets I found exciting is, as he mentioned, new head-mounted displays allow new input devices, so you can use electromyographic input, electroencephalographic input, things like skin conductance, body posture. You can do gesture sensing through different sensors using things like radar or LiDAR-based techniques. And then you can combine all these input modalities, say, for instance, interfaces that can change their behavior according to the user's heart rate or skin conductivity. And you can combine these modalities in different ways. And of course, fatigue and comfort are an issue. So this is an example. Meta-neural link also allows you to have wristband input. So there are a bunch of devices that allow you to detect gestures using wristbands. And then you can use OpenBCI to combine VR with different sensor modalities, or something that interests me particularly is controller-free input. So there's a paper tomorrow called Head Zoom that summarizes that. It's the idea of Head Zoom is to do zooming and panning just by moving your head in different ways. No controllers. It's a kind of interface of look, man, no hands. So your hands can be free for doing other tasks. And other, so this is a relatively old paper from 2017 by Ken Pfeiffer et al. Using combining gaze, eye gaze, and pinch. And this is also an interesting topic. And here's an example of gaze and pinch interaction in VR. Let me see. Maybe I can play this video a little bit. So this is an example of a multimodal interface where you can combine eye tracking, where that's the circle you see. So the circle indicates where the person is looking at, and then you can do gestures to manipulate that content. There are several research techniques, especially selection. Eye tracking is very powerful, but it poses interesting problems like noise and difficulty in controlling the input. But this is an interesting research area. Then you have tools for ergonomic design for XR, and it's an example of XR ergonomics using physiological model to compute compute the ergonomic interaction cost, and they have this is a 2021 paper, and they have a repository of the demonstrator and interaction techniques.
We present XR Ergonomics, a toolkit to create ergonomic user interfaces for augmented and virtual reality applications. With the rise of augmented reality and virtual reality applications in different fields, creators face new challenges in user interface design, such as the physical aspects of interaction. Users can experience discomfort or even injuries due to prolonged mid-air interaction with 3D user interfaces and unusual moving patterns. With XR Ergonomics, we aim to make existing metrics available to creators by estimating the ergonomic cost of interaction at each reachable position in the user's environment. To compute the ergonomic cost, we introduce a three-stage pipeline. First, discretization of the interaction space. Second, computation of arm poses. And third, computation of ergonomic cost.
Okay, more details on the paper, of course, and we'll make our slides available shortly after this. And then another topic that I referred a little while ago is using generative AI for XR design. And there are good examples here. So you have text to 3D models that are starting to appear, image to 3D models as well, but we're still short of creating full virtual worlds. And then we can use AI, of course, to automate repetitive design tasks for interface design, to simulate. We can also use generative AI to simulate users, cheaper than making tests. And we can test interaction patterns, identify potential usability issues. And you can get real instant feedback on our design choices, and that improves our productivity. And of course, here you have an example. I'll go quickly over this slide since we are a bit short of time. And I want to cover all the interesting topics like collaborative and social VR. Mark has a lot of work on this area. So exploiting gaze, gesture, and nonverbal cues to try and make our interactions in extended reality richer and allow things like synchronous collaboration. One topic that interests me particularly is proxemics in VR. Have you heard about proxemics? Okay, 3, 4, 5 people have heard. Okay, so proxemics essentially is this thing that dictates how social distance or personal distance can determine our interactions with other people. For instance, if I look at you, I'm obviously wanting to interact with you, okay? And then we can get real close, perhaps too close for comfort. So this is proxemics, okay? And we can use, one thing that strikes me personally is that proxemics has not been very much explored as a tool to facilitate interactions in virtual and mixed reality. And this is an example. It troubles me that when we are doing a remote assistance type of task, I can see two arms emerge from my virtual body. And I think, gosh, somebody is using my body or occupying my body. This is impossible to do in a virtual, in a real world, but it can occur in mixed and in virtual reality. And we've conducted user tests to measure to what point this situation is discomfortable or not for people. And then you can have these different degrees of closeness, person to person, or more social interaction. There's psychology work explaining how, to what degree this affects or not the interactions between people in the real world. And it's also culturally dependent. So, for instance, Finnish people are very picky about getting too close to other people, except when they're all naked in the sauna. Go figure. Whereas people in the south of Europe tend to be comfortable with more closer interactions, and people in the north of Africa also tend to be very comfortable with close conversations. It's interesting to see how we can do how much of that we can transpose to extended reality. Then gaze cues, so sharing gaze cues to see where I'm looking at so I can improve communication if you're a remote participant, and use different cues depending on behavior. And again, supporting asynchronous collaboration, that's an interesting topic when we are not virtually present at the same time. How do we make interaction available, say, in different time, different place settings? I don't know if you want to say extra words about this, Mark, since I know that's some topic.
Well, this is a example of work we're doing in our lab about asynchronous collaboration, which is another area which has not been well explored in terms of design. So you just keep on clicking Joaquim and it starts an animation. So the idea is you've got a person in the real world who's doing some task, in this case assembling a motor, and then you have a novice person who wants to try and do the same task. But keep on clicking, yeah, you'll see the person looks at some plans, doesn't really understand how it's to be done. And so the idea is that you could have a recording of the person doing the real task and play that back in AR and show them doing the task, and then the person can sometime later learn how to do the same task from that person. If you go to the next slide, it'll play a video showing it working. Just keep on. So the first part is recording, so you can record a person doing the real task, and keep on going, keep on clicking, and with hand tracking and object move, keep on clicking, Joachim, and you record the spatial data, and then you have a second user that can then view that recording in either VR or AR, and you have an avatar shown of the first user as well. Keep on clicking a bit more, and you can see the person's view. And there's also a timeline as well, so you can scrub back and forth in the timeline to go any time in the past to see what happens. It's a very nice way to fully understand how somebody performed a task and being able to repeat that task as well. So you can go to the next slide, Joachim. I think yeah, now you can start talking about this.
Okay, yeah, and just a footnote there that we did publish in 2023 a survey on these interaction techniques in extended reality for collaboration and tutoring. Ethical issues, so okay, persuasive technology. To what point we can, is it ethical to use VR content to affect emotions and modify behaviors? Well, maybe I want to quit smoking and I want to have a VR interactive program with subliminal images. By the way, this is kind of illegal to be used in publicity since the late 50s in the last century. But you can try subtle variations of this technique, and especially if maybe if the person has consent. Now this is starting to get interesting. Facial recognition, space capture, and personal data. There are now certain types of makeup that you can use to fool facial recognition cameras and systems, especially when you know what features in a face they are looking for. And then you have problems with simulator sickness and distraction, and the long-term effects of using virtual reality. People have started looking at this, and there are recent publications about what happens after we use extended reality or virtual reality or mixed reality for a long period of time. This can induce cognitive problems in many people when you use a virtual reality headset for say several hours. And here's an example. You can also identify people even if you don't look at their own faces by the way they perform certain actions, and you can recognize people. This is recent work that shows that you can recognize people with about 40% accuracy using relative distances between head and hands, and head motion alone yield already 30% of effects. Other things, trauma. I watched someone commit suicide in VR and it freaked totally me out. In VR, the goal is emotion, presence, and sense of self. What are the consequences of having a traumatic in VR experience? Is that ethical? I mean, if you watch gore in VR, should we do that? And so VR for extended reality is even easier than ever before. So we still need to do research on making this easier to use and to prototype. New interfaces provide new opportunities, multimodal input, physiological sense, etc. AI is providing new opportunities for enhancing the user experience, I guess. Designing for collaboration, for me, this is still a fertile research ground, and there's lots more. Okay. Where do you go if you want to look for more resources to help you teach courses or improve your interface designs? So one is this XR prototyping website, http://xr-prototyping.org. They have an XR-M MOOC on Coursera. It used to be that you could do free audits. Coursera is changing their policy a little bit. And of course, these are two favorites of mine. I love this book by Bill Buxton on sketching the user experiences. Bill Buxton is one of the founding fathers of our field of HCI, and he explains the many different dimensions of sketching. And I like the subtitle here, Getting the Design Right and the Right Design. Strongly recommend these two books. And this is a workbook authored by Saul Greenberg, Sheila Carpendale, Nick Marquardt, who's now at Microsoft Research, if memory serves, and Bill Buxton. I love this book. There is a tutorial. I use this extensively in my XR Introduction to XR courses. Highly recommend it. And if you should love sketching if you are into user interface design. That's my personal thing. And other excellent books, if you don't, you should buy these definitely. Oh, by the way, let me do some sales pitch here for ACM books. If you are ACM member, you can get a subscription to hundreds of ACM books by like $20 per year. I recommend it to my students, and as far as I remember, ACM is now developing agreements with universities where your students can get access to this content for free. If you are teaching VR courses, I'll recommend 3D user interfaces. Fantastic book in terms of interface development. Our own Dieter Schmalstieg and Tobias Zoller have this excellent book on augmented reality. Both of these are ACM book. All of these three are ACM book. Oh, and of course, my favorite, this is my textbook for the introduction to VR, the VR book by Jason Gerald. All good fellas. So highly recommended. And you have another UX of VR website, uxofvr.com. It provides codes, design ideas, video books, articles, slides, code, etc. And shameless plug for our forthcoming ACM book. We are dying to get this book published. Interaction Design for Extended Reality by Mark, yours truly, and two other colleagues. And last but not the least, this is the website where we're going to publish the slides, so you can scan the QR code and get the pointer to that slide, and you can contact Mark at Auckland University. Twitter is at MarkBNB00, and this is his LinkedIn page. This is my university address at the University of Lisbon. And well, for shorters, this is my IEEE address. That's far easier to type. I'm at JGeorge in Twitter, and this is also my LinkedIn page, Jorge J. Okay, this has been quite a journey. We have still 15 minutes, a quarter of an hour, so you feel free to take some pot shots at us, ask questions, any questions and any comments that you have, things that you liked, things that we can improve, please shoot. Yes.